In this episode, we will describe asynchronous calls from Smalltalk to external library functions. Now, when starting with asynchronous calls from Smalltalk to external functions, we will have a short back to the synchronous calls. As you notice, the external native execution thread is doing the call and it goes back, and no Smalltalk is done during this call. When using asynchronous call, this changes. When doing the external call, the native execution thread starts an additional native thread. Then, with this additional thread, it executes the external library function. Then the additional execution thread terminates, and the result is merged into the main native execution thread. During this external call using the additional native execution thread, the calling Smalltalk process is blocked. But all other running Smalltalk processes are handled by the main native execution thread. Therefore, it is not allowed, or not pretty well way of programming, using asynchronous calls from the GUI thread. This would lead to a blocking GUI thread, which means that VASmalltalk goes to polling and the CPU goes up to 100%. Therefore, when doing asynchronous call, you always have to work with background Smalltalk processes actually triggering the external function call. Now to the examples showing asynchronous calls to our VASmalltalk library. In VASmalltalk we have defined a function which is called long-term action. And what does it do? Well, this function needs about 4 seconds to run. This is a long time function. It assumes that we have an array of single floating point precision values. It's also assumed to be called via standard call. And what it does, it changes the first element of this array first to 1, then waits 2 seconds, then to 2, waits an additional 2 seconds, and then the last change is the value 3, and then it returns. And from Smalltalk, we want to call this function and look how the value changes within this array. And here's the Smalltalk function. The function definition, we have the array of a single floating point precision array, therefore we have to give a pointer to this array. We don't return any values, and now we create an array with 2 elements in Smalltalk memory by using new. And then we fork a Smalltalk process, and within this background process we fork an additional background process which just do the asynchronous calls. This structure is needed, otherwise the background process would be blocked by this asynchronous calls. And as I mentioned in the introduction to this topic, we shouldn't use asynchronous call within the GUI thread. As I mentioned, we create an array in Smalltalk memory and initialize the first element with the value 0. And then we will make a call and look what happens. Then within the Smalltalk code, we wait 10 times, each time 500 milliseconds, and look how the value for the first element changes. Now let's start. You see, the GUI is still responsible due to the fact that we do an asynchronous call. And that's it. Here are the result. Perhaps you notice that the example started with the Smalltalk memory approach, and then we changed, then we do the platform function. As you notice, we have initialized the first element to 0. And in addition, we have initialized the second element to 1000. But after the function call. Then we wait, and you notice that nothing changes, but only after 3,500 milliseconds the value ends up with 3. Therefore we are missing the value 1, the changes to value 1, the changes to value 2. And at the end of the example of the external function call, the value for the second element is 0. Therefore somebody has set this value from 1000 to 0. And this is one of the problems you have to think about when doing asynchronous calls. We have allocated a Smalltalk-based object with a byte array, but it's all memory, Smalltalk memory based. And when doing an asynchronous call with byte word oriented instances, the Smalltalk virtual machine copies the content of the byte array to a fixed memory, then do the asynchronous call. The asynchronous call is working on a copy of the fixed memory. And when the external function finishes, it copies the array of bytes back into the original object. And therefore, during the call, you don't see any changes because you are still working on the original Smalltalk memory array. But when the function finishes, it was copies back, and suddenly you see 3.0. And well, the 1000 vanishes simply due to the fact you did a change to the second element just after the call, just after the copy has been done, and therefore the changes to 1000 is simply undone again after the copy back to the from fixed memory to the original Smalltalk object. The whole situation changes if you do the allocation not in Smalltalk memory but in external operating system memory. You simply have to change the new to calloc. And now we will do this example again. The GUI is corresponding due to the asynchronous call, and now you can see that it perhaps behaves as you would expect. The 1000 is still there, nothing vanished, and you see the changes of the value. This is simply due to the fact that when doing the external function call, the virtual machine noticed, well, it's not a Smalltalk object, it's an external memory object, therefore I just give a pointer to the external memory, and now both applications, the Smalltalk virtual machine with the Smalltalk code running in the background process and the external function call executing, are working on the same data structure, and therefore you see here no changes.